Hello everyone, welcome back to Tableau training campaign. Today's video will be session number 6, which will be mainly talking about the advanced mapping in Tableau. In case if you are new for this in this training campaign and you don't have much experience with the mapping in general, working with mapping, I highly suggest that you go back and watch session number 5 from the Tableau playlist in my YouTube channel. Because session number 5 was mainly covering the basics to intermediate level about the mapping, so I highly suggest to watch it before going to the advanced level. So today's video will be mainly talking about 5 main points, which is speaking about what it means by spatial data, what it means by spatial files, what it means by geometry field, just to give a quick introduction in case if you are not familiar with this kind of terms. Then we'll be talking about the main spatial functions, which is the calculated fields, which mainly working in the mapping, for example, to calculate a specific distance between one point to another, to convert the normal latitude and longitude into the so-called geometry. I'll explain this part later on with practical examples, and working with other things, for example, creating lines from one point to another, calculating the area and buffer, and so on and so forth. Then we'll do some spatial joins between different data sets. If you have two different data sets, two different data, yes, but within the data sets, you can connect all of them through the geometry field. You can have a connection between both of them to get more useful insights. Also, this will be covered with more examples. Then we'll be talking about multi-layer design, how to have multi-layers in the same map using different data, and buffer analysis in more detail. So the first part I would like to highlight about the spatial data and what kind of spatial files we have and what it means by geometry field. If you go to the bottom down here, you'll find the dashboard number 3 here, and this data will be imported to my blog, and you'll find all the materials within the video description. You can just get it there and download it and use it. So this pictures is quoted from the official website for Tableau. So you can see this just quickly explain what it means by spatial files and how you can create Tableau maps from the spatial files. So simply the spatial files, it's just kind of a shape file or a shapes, either polygons as mentioned here, or points, or line, or whatever. And these kind of files or shapes can have a different format. It can be shape files, can be map info files, can be KML, it can be GeoJSON file, or topo JSON file, or even this ESRI file, geodatabase. So this is the format which can be accepted by Tableau. So if you have any file, a spatial file with this format, it will be accepted by Tableau. So it's how you can get this or where to find this spatial files. It can be either directly found from, or you can directly find it from official websites or official open the data portals. For example, here some examples. This is London Data Stores, South Africa. If you went for the website, you have the link here. You can click it, and if it take you here, you can download it and start working with all of these data. For example, the shapes here in the right side here, this is all exported from this particular area. So if in case you would like to have a more practical examples, you can download it and start doing your own working. So this is one way to get the data. The second way, which is the main part we usually do, is doing our customized data. For example, we can draw polygons or routes or lines or points using different tools, Google Earth or QGIS. Then you can import it later on to the Tableau, import the spatial files to Tableau. So this is what we are going to do today. I'm going to work with the customized files, which these files having a sector view and having some polygons and also other points. I will show you quickly now the dataset overview where we have it. So this is what it means by spatial files. Later on, when you import this spatial files to Tableau, it will create something called, as mentioned down here, geometry field. This geometry field, this is kind of a combination. You can mention a combination of latitude and longitude, but there's just you can drag it and drop directly to the so-called details here, and you will see it later on, and it will directly draw your map. But just taking into your account, once you draw it to the map, assume that you have hundreds of points or thousands of points. Initially, it will be aggregated into a single point. So you will need to do two methods to disaggregate them, either to add something additional to the level of details. For example, you can add a sector level or points or something unique in order to get all the data points, or you can just go to the analysis within the dashboard, the Tableau, to do the disaggregation. I will show you all this shortly. Just don't get confused about it now. So this is the main things now. So now let's get started. But before getting started, I would like to introduce what kind of dataset overview or dataset we are going to use in this session now today. So moving forward, this is the 3 datasets or 4 datasets we are going to use. The first part here, this is within this sheet. You can see this particular sheet. This is like just a normal XLS file, which have 1,000 of points, which is like these points can have a different speed or different latency or jitter or whatever. So this is just the points in the map. Then I created 2 customized polygons. One polygon, you can see this kind of mini polygons here. And I did something like for each, I used QGIS Voronoi tool to create a polygon for each sector. So you can find that each sector has its own polygon as highlighted here. Okay. So this means that I have 2 datasets or 2 different data, one for the Voronoi polygons and the other one for the sectors. And the main idea that both have exactly the same data, but just covering different purpose. Then I have the third one here. It's just the site locations, site IDs and site locations, and this will be used in the buffer part analysis. So this was the overview about datasets which we are going to use today. So now let's start with the first part for how to import this kind of spatial files and start creating a map using them. So as highlighted in the bottom here and in the top this will just be simple one, how to import your spatial files. So simply as we usually do, you need to go to the data source and bottom left here, as you can see, this data source, right? This area, you can just need to get it, click it here. Then here you will have different things, as you can see in the left side here, you have different data types: Microsoft Excel JSON file, Microsoft Excel PDF spatial files. So this is what I'm going to use today, the spatial files. So I need to click here. I will use this one along with the XLS, but initially I'll start with the spatial files. So I will click this one. So you'll find in my data now I have 2 things: the sectors, as I highlighted earlier, and the polygons. So I will click in sectors, for example. As you know, that once we import the sectors, it will be coming here, already uploaded, both because you have 2 files under the same folder with the same format, which is the GeoJSON, as you can see this in this area here, right? So that's why both of them here. But since I click the sectors only, you'll find the sectors initially directly being imported here to our database. So you can first rename this instead of sector, just make it, for example, make it as spatial files, okay, for now. Then this is what our data looks like. As you can see bottom down here, you have the site ID, cell ID, longitude, latitude, and many other different information. If you move to the left, you'll find you have geometry at the very end, and this is the most important. This is automatically created. This one is automatically created by the Tableau. It's called create geometry, which we'll be using to plot our maps. So moving forward here, well, let's go back to importing files. So now we have all our data here in the left side. This is the data on our table. So it's very simple part. The geometry field, you just need to take it and drag and drop it into details. So once you drag it and drop it into detail, it will be importing your data, okay? But the most important part here, look into this. Once I import it, it's just coming as one single mark. If you look into the left side here, down here, it's saying this is only one mark. So in case if you like, you know that you have many sectors. If you look into the figure here, you have one sector for each, for example, sector, you have different cells. So if you would like to get this kind of information, you need to disaggregate it. So you can have 2 methods, either to use a unique something here. For example, let's assume this code. This code is just, if you look into the code, let's open it and see what you have. For example, the code, this is just a kind of a sector ID. So if you drag and drop this one into the details, you'll find that the bottom line mark down here, it will be changed. For example, let's try. This is the first method. Drag it here, 42 marks. But still, this is just a sector ID. It's not a cell ID. So in this case, still there is some additional information you can get it. So for me, the best way to do this one when I work with the spatial files and mapping, I will just go in the top left here for the analysis part, as you can see, and just click here and just remove the aggregation. So you'll find that the 1 mark now changed to become 81 mark. And even if you hover over your mouse here, you'll find that you have a different information. For example, here, let's add, for example, the code just in the label, just to have more information here. Or not in the label. Let's move it from the label to the tool tab. Okay. So I will move it, yes, to tool tab now. So if you hover over your mouse, that you'll find that, yes, you'll find, for example, this one 2000-2002, this one 2000-001. Let's add the frequency band better in the tool tab just to give more visualization. See, this is called a frequency band N7, this frequency band N1. So now it's being segregated if you look into here. So now you can work with all our datasets because you have 81 marks. So this was the first part, how to import your spatial files. It's very easy, but let's just do a quick formatting before we move to the next part. Go to the map in the top here and just change it to outdoor mapping. Okay, so one thing you can do, for example, now to start getting some visualization, for example, I will drag and drop this frequency band to the color. So if it looks into the right side here, we have now different colors here, but it's not yet showing here because each one of these having a different cell radius. For example, the N77 having the smallest cell radius, so it's coming under the blue one, which is N1. So you can just move the legend to the top, and your data will be start coming. See, and same for N41, it's having a cell radius, small cell radius, so you can just move it below N40, so you find it's coming now. And also for N7, it's having a cell radius less compared to N1, so it's underneath of the cell N1. So now see, now this is how restrictor views looks like. And again, this was a customized polygons I created in QGIS, then I imported here. So this is the first part. The second point I'm going to show you now after a few minutes, now how to import the other data sets and how to do a multi-layer to add the different multi-layers. For example, I can add now the polygons here to get the polygon view, and I can even merge the data now. But if you look into my data, there is no yet any useful information here. For example, it's all about just the database. I have a database, sector ID, frequency band, all these kind of things, but I don't have yet, for example, throughput or traffic volume or sales or whatever. So this will be coming with from when I import the points. So now let's move to next part of how to have spatial joins and what it means by spatial joins and how to have different multi-layers, which I already give a brief introduction about it in the previous session. Let's move forward. So now moving to the second part, which is related to spatial join and multi-layer map design. So this is just, first of all, I would like to tell you how you can add two different layers or three different layers within the same map. So again, now I would like to get additional information. Now this table, which I have it here, it's just for the sector ID. Now I would like to go to the data source. Previously, when I imported the sector ID, it's also here in the left, it's having another information which is related to the polygon, right? So I would like just to use this one. First of all, if you drag this polygon here, you can create a new base table, but this will not work because it needs a relation to give you, like kind of an error that there must be a relation or must be kind of a join between both of them. So since we are working with a special file, so it's the best way to have something called spatial join, just to join both maps together, the information both maps to join it together based on the geometry field. And geometry field, as I told you before, is kind of a combination between of latitude and longitude. So let's remove this one and show you what it means first by the spatial join. So just before showing directly from here, I would like to give a quick introduction about what it means by spatial join. So if you look into down here, this again, you can get the information from, you can click the image and go to the official website. It will explain to you what it means by spatial join. If you look into the left type here, there is join types. This is like if you have a different data and they would like to join them. So you can have a different types of join types, either inner, left, right, full outer. It's very explained and it's very simple. For example, it's saying if it's inner, when you use an inner join to combine two tables or two different, for example, maps, the result of the map or the table will contain the value that matches both of the tables. Whatever not being matched in the both tables will be discarded. And here it will just take the left and discard the whatever in the right. Here will take whatever in the right and discard whatever in the left table. While the full outer, it will add all the complete information. So even if something not matched in one of the tables, they will add just the null information. It will be combined on null and keep the other table as well as. So it will add both of them. The union is kind of appending both data. I explained this one in the first session, and I will explain more. I will have a specific session later on about this particular area to discuss it in more details. But union means that if you have, for example, let's say 3 Excel sheets and all of them following the same format, but have a different, for example, information, but exactly the same columns, same rows, and everything, same columns, you can just append it on top of each other using the union. Again, I will be discussing this in a separate session, but for the meantime, I would like to use the special or join types using the join special files to join my data sets. As I go back to the data source here now, I have the area polygon and the sector. Now I would like to merge the area polygon and the sector as well. I think yeah, I used to have the sectors here, so I will replace it again. So now I would like, yeah, this is what we used to have from the beginning. Now I would like to add the area polygons with this one through using this so-called spatial join. So you need just to click and double click here. Then you will have this opening. This is called your physical layer. This is the physical layer. This is your physical layer, and this is being called now from one table. So simply, you can just drag and drop the sectors here. If you drag and drop under this one, it will just make a union. But this data is not the same, so I would like to do this kind of spatial join. So you just drag it and drop it anywhere here. So directly you can see it starts creating asking you for which kind of join you would like to have. So, for example, I would like to have the inner, just to discuss whatever information. And again, I'm going to use this kind of spatial join, which is based on geometry, which is the coordinates, latitude, longitude. And also the same here, I would like to get the geometry as well for that part as well. See, this is called geometry sector GeoJSON file. So I'll click here as well. But the main idea that it cannot be equal. If you are doing a spatial join, which is based on the map, so it must be intersect. It was work only with intersect. So once I click this one, you'll find now my two tables being combined. If you look to the bottom down now here, let's close this physical layer. If you looked into this table information now, just go through it. You'll find initial it's called sector GeoJSON, and the very end here, you keep moving. You'll find sector JSON, sector GeoJSON, sector GeoJSON. For example, this one called sector GeoJSON. Then you'll move to the right side here. You'll find start the name changing to sector GeoJSON one. Right? I did by mistake I joined actually the exact same data source, and this is not correct. We would like to replace this one, sector GeoJSON, with the area polygon. So I remove it now and just add this kind of polygon here and quickly do the same exercise, which is, it will be directly taking effect now. Look into this part, let's click it. It's just geometry from the first one and the second one and intersect. So if I look again to the data, I'm expecting to find the table on the left will be sector GeoJSON, and the table on the right within the same table merged now would be called area polygon. So if I look down here, look into here, it would be start with sector JSON, as you can see here, right? GeoJSON, then move to the right side here until you will have all the information. Then it will be start appearing with area polygons. Usually it should give a different colors, but it's not now, so it's fine. So now we'll find that you have area polygons with other information being merged with this one using the intersect. This intersect or the join, it will be much more clear when you go to the when you import the data points. You will really understand it. So keep with me now. If you're confused, you will understand it more in few minutes once we go to the when you join points with polygons. You will understand it much better. So keep it for now. But we just here simply we merged both data sets into one here, as you can see, and it's having this kind of circles information here. So now let's move now to the second sheet here. So simply now what I need to do, I need to draw a multi-layer map design. So if you look into the first of all in the left side here, the information completely changed now. You'll find initially this dimension having the area polygon. Then the second one have the sector GeoJSON. Then again for the measure, it will have the same separate for area polygon and sector GeoJSON as well, right? So this means we have all the information now. So initially we imported here, if you remember, it was about the sector. We imported here into the map. So now I would like to get the geometry information for the new added information, which is the area polygons. I would like to import the polygon here. So we need just to click it, then drag and drop it to the map. Once you take it to the map, it will show this add marks, a marks layer. So we need just to click it here. See, now it's coming here on top of it. Two things here. First of all, when you uploaded both of the information, it's coming in the marks down here in the left side here. So you'll find it's coming with the exact same name, or with geometry here, it's called geometry area polygon. So better to rename them to avoid any confusion. For example, this one, if you rename it, it's called geometry area polygon. So just call it polygons. And the second one, this is for the sector, rename it as well. Just click in this mouse, then make it as sectors. Okay, so you know now. And second part, you'll find that since polygon is on top, so the polygons is overlapping the sectors. So you can even move the sector, click in that here and just move it up, or you can drag and drop. So you'll find now it's coming on top of it, and you can play around with the formatting. For example, if I click in the polygon now, I can go to the color here, and for example, reduce the opacity. Okay, just to get more better vision. Okay, so now I'm reducing the opacity as much as I can. You can see now the opacity being reduced a lot here. So now we have the two layers on top of each other. Now, till now, I don't have yet an information to get a useful insight. For example, I know that there is a lot of testing being done here by the users using crowdsourcing data or whatever. For example, OCLA or speed test or whatever, and many points within each area having many points. So I would like to get the performance to know which area here is performing bad, or showing bad speed or bad jitter or bad latency, or a specific KPI is outperforming or having a very bad performance. So this, now we need to import additional data sources, which is the points, where I have many testing being done even by drive tests or whatever, and to try again to merge all of them using the spatial join again. And this will be very, very important because you will understand more the spatial join. So this was about the spatial join, initial introduction, and multi-layer map design. I will move now to the next part, which is about the so-called something called MakePoint and the spatial join again, but with the points. So let's move forward to the next part, where you will understand more, where you can get more very useful insights, as you will see shortly. So again, here, this is now we will do multiple things here. First of all, I would like now to import again my XLS file, which is one of the dataset I highlighted at the very beginning, which is including the points or the testing in the map. Then once I upload it, I would like now to get to merge it with our data, to have kind of a merge, which you will be using this special files. So initially, I will go to the data source now. But just to be able to explain, I would like first to import it as a complete new data source. Okay, but just a one quick note: you cannot make a spatial join, which you join the files, which I did it here in this example inside this one, if it's uploaded in different data source. And again, what it means by different data source: if you look into the top here, this is one data source. If you uploaded a different data source, it will be from here. This will be new data source. It will become under this one. This is a new one data source, and under this data source, it having a connection. You can have a different connections using different format. For example, this is special file. I can have another connection using XLS. I'll show you shortly. But first, let's import a new data source using the Microsoft Excel. Then this is my points, okay, in the map. So it will take a few seconds. Now it's being imported. And if you look into bottom here, you have now, if you click here in this area, you'll find that you have two different data sources here, the spatial files and the CS data speed test. So I'll call this one, for example, points speed test points. Okay, for now. So now this one again is highlighted. It's having many information. It's having date, hour, region, city, latitude, longitude, operator name, device, technology, and the speed, where we have multiple speeds. So this is kind of very important for us now, because now we can start doing some visualization if you were being able successfully to merge all the data together. So I will go back to the third part here, and I would like to drag and drop this one first, the points within this map. So you'll find first of all in the top here, here, this is your now datasets. You have two different dataset, the special files and the speed test points. If you click here, it will show the special files, and you click here the speed test points. First of all, I would like now to draw this one again to add additional layer, multi layers. Third layer with the points. I would like to get the points now in the map. How we can do this part? Usually you need the so-called geometry field, right? So if you look into the data here, since it's XLS, it's not a spatial file. So the Tableau will not generate the so-called geometry field, which is a combination of two different data sources. Because again, this is not a special file, it's not a specific file, it's just a normal latitude and longitude XLS file. In this case, you need to create your own geometry field using one formula called MakePoint. So if you click here, I'll just create calculated field. Let's call it points geometry. Okay, so there is a formula called MakePoint. This formula, it's a combination. In case if you'd like to get the explanation, you need to click here in this area. It's saying that this one MakePoint, it's giving two numbers or two different number. For example, this return a spatial object constructed from latitude and longitude. This is just simply explaining how you can get the geometry field. So for example, here it should be latitude first. Latitude, which I use it in this data source here, down, then comma, longitude. Then you click apply, then you click OK. You'll find now it's being calculated here, this one. So now simply you can drag and drop it here into the maps here. So very good. So now I have 6,000 of points now. Let me just here, it's coming here as point geometry, okay? Let me rename this part. Let's first change the formatting to circles and just do some formatting, reduce the opacity, reduce the color, and even reduce the size a little bit, okay? Just to get more visualization. The most important, you can see now, it's constructing of 18,646 points. If you remember again, just quickly say, if I remove the disaggregation, I make aggregated measure, this will be appearing as only single point or 6 marks because I have a legend. See, it's only 6 marks here, only, okay? So you need to disaggregate all of them just to have all the data information. So now let's zoom into the area where we have our data, all the data there. If you zoom in here, you'll find now you start getting many points within, let's increase the size a little bit just to get it more visualized. Yeah, you'll find, for example, you have here many points within this area, right? And many points within this area here and there, and some areas doesn't have anything, right? So now the main idea that I would like now to visualize my data set. I would like to know which area is performing better or showing a good performance or bad performance or whatever. This can be in a very large scale, but I'm just showing a very few sites here. So now we need to do the so-called special file, spatial join. This spatial join now for you it will be more clear. For example, I would like to join. I will tell them whatever falling within my polygons as a point, I would like to join it, the both data together to be able to visualize the data using this data source. So, for example, I'm expecting if I did a spatial join using, for example, if I go here for this part here, if I did this inner one, what I'm expecting between the polygons and the points, if I go back here, I'm expecting that whatever falling within the polygon, which is the points, will be still there, and whatever outside would be discarded. If I make full outer, it will keep everything, okay, the outside and inside, but only the area in the middle here can be used for your own. It will have the same information. So let's try, but let's go and try to merge them, both of them, as I highlighted before, to have this kind of spatial join using the points now. But again, the most important now, as I mentioned, and I intentionally made this one just to let you know, you cannot make a spatial joint if you are using different data source. So for example, here I have the special files and I have the speed test points, right? So if I click in speed test points, this one I cannot now drag and drop because it will completely disappear. So you need to import again the data, which is the CS data or the speed test points, into the special files here. So you need to go here, the special, let's take it here. I go back. So you have now one connection with a spatial file, right? You need to add a new connection with the XLS. Very important. This is very, very important. Then you can click it here. then it will be appearing now as a second connection, which is called speed test points, and the old one is still there, which is called sectors. Now you can drag it and drop and try doing the merge. So this is a very important. If you would like to do a special files, all the files must be under the same data set, which is the same data source, sorry, same data source, but maybe with different connection. One connection was whatever special files, another connection was XLS or any other format. So let me remove first the old data set, which is called sector test points. If you would like to remove the complete data set or that source you added, you have to do it from here. Right click, then you make close. Okay. So now the points being disappear. So now I will just go back to the data source and I will do the spatial join now. Okay. Now here I have my data. I will again double click here to get all the information. I will drag and drop the CS data here. Okay. I will tell them I would like to do the join between. I would like to use this spatial joins from the table on the left, which is data source. I need to use a geometry field. Okay, which is here I will use the area polygons. I will drag the polygons and I will check. Would like if it intersects with the data points, I would like to keep it all together. If it's inner, it will discard whatever outside. If it's full outer, to give you all the information. So now the C data, it must have a geometry as well. Since we don't, this is just an XLS with latitude and longitude. So again, to say it again, Tableau will not generate the geometry. You have to create it by yourself. But it's not being created because I completely delete or remove the previous data. So we can even create it here within the information. If you click create join a calculation field here, you can just, again, if you remember, I can make point to create my geometry field. So I can say latitude, it's giving latitude and longitude. Latitude, long one, it just give one and one because the other data as well having same name, latitude, so that's what give additional one. So I'll click OK. This is mainly for the data for the CS data. Okay. Then initially I would like to keep it as full outer just to show you how it looks like. Okay. Then I will close it here. Full outer, again, we keep all the points. Inner join, it will just keep whatever intersect and it will discard whatever outside. So let's see now. So again, if you would like to confirm now the data is there, if you look into the bottom down here, it will be start with sector GeoJSON. Then we are expecting the second one will be area polygon. Then the last one will be CS data. So let's move. And I'm expecting this CS data will coming with different colors because now it's having a different format, which is XLS. For example, the first one will come with the blue. The second one will come with the orange, which is this colors here. So we're expecting when I move to the right, I'll find the CS data with orange color. So if I move to the right side here, you'll find sector JSON all the time here in the naming, right? Let's move forward. Then you will start seeing once, yeah, now it started for area polygons, which is the second one. Then I kept moving to the right. I should start seeing CS data with orange color. So I will keep moving to the right to see this part. It will be merged with a new information now. Move to the right. Yeah, see now it's ended here, geometry. And now it's showing the data, the data for the CS data here, as you can see with the orange color, matching with this color here. And now it's giving other additional useful information, which is related to, if you move to the right, for example, here you have the speed, you have the latency jitter, so I can now start getting some useful insight. So now once I make this full outer, I'm expecting just what I will get now. If I go to the MakePoints here, so first of all, look into the left side here, you will find that all data is coming now together, sector GeoJSON, CS data, and the area polygons, okay? And this is for the dimension, the same will be for the measure down here, okay? So all data are coming here together. So first of all, I would like to plot my points in the map just to have all the information together now. So how you can plot the points, we need to look for the geometry field, which is not created because I deleted before. So the first part you would like to do, go to the create calculated field, click in your CS data, or you just create calculated here and just name it points geometry. And again, to create the geometry field, which is a combination of latitude and longitude, this is using the MakePoint, right, formula. So I would make latitude. I have now 3 different latitude. The first one, I know it's for the first table, which is a sector. The second one for the area polygon. The third one, which is, if you look into the naming down here, latitude 1, it's under the CS data. Look into that here. So I know that I need to select here because I'm creating for the CS data or the points. This will be for latitude 1. Then comma, longitude 1 again for the same one. Then I will click apply. Okay. Then now I have the geometry field. Again, you need to drag and drop it into the map. You'll find marks, add marks. So once you drag and drop into map, see it's coming now. See now all the points are coming now here in the map. But again, remember that now it's coming as a cold geometry, point geometry. Let's rename it just to have a very clear. So I'll just call it points or speed test, whatever, but just to have a segregation or to have a clear naming. Then I'll change this one just to a points here. Again, I will keep the size as it is, and then I maybe change the color here to red. So now my points are inside. So now what kind of things we have? Before trying to do some visualization, I would like to show you what it means by spatial joins for the just showing this kind of intersect only, or mean the type where it's showing both of them together. I would like to discard whatever doesn't have points within the polygon. So if I make the other type of joins, which was this one here, which was this one, right? The inner join. If I make the inner join, what I'm expecting, if I go back here, I'm expecting that, for example, whatever outside the polygons, which is all the red circles outside here, these all will be discarded. All of them will be discarded. It will not be there. It will be filtered out. And even the polygons with this, for example, this one doesn't have any points. It will not become, also the area in the middle here doesn't have any points. So it will become with nothing, okay? All of them will be discarded. So just to quickly show you, if I go to back the source here, I double click in the physical layer, then I change this one just to inner, okay? Now change it to inner. Let's go back to our data to see what we'll get. See, as expected, and now I just got the information only for the area which is being intersected, as very, very highlighted, that only the polygons which are having a falling point is being there or being highlighted. I would like to keep all of them for now, so I'll go back to that source, and I will again double click, and I will just give it full outer, which is include everything. So now I already changed it. Let's go back to the map. I'm expecting all the points will be coming again now. But again, we have a relation now, so we can even start doing our analysis. Go back to the MakePoint spatial joins. So I have everything now. But now the good news now, now whatever falling inside here, this means I can start using the, for example, under the CS data, I can use this, for example, speed, information, jitter to be doing some visualization. So let's first do some examples here. What I need to do, I need first to visualize here what kind of speed within or jitter within each polygon. Okay, so you can take the jitter and go to the polygon, click on the polygon first. For example, drag and drop jitter, for example, into color. I would like to give a different color for each of the polygons based on the jitter. Okay, then I will right click here, make this one as an average. Okay, look into the jitter here. This color is coming. If you look, let's change the color to make it more. But if you look into that part, you'll find that the more darker, this means the higher latency. But let's change the color code to make it more clear. That color code, then so you can either, for example, play with the color code just to increase the opacity. For example, if I increase the opacity now, you'll find the more darker means the worse the performance. But let's try to change the color, for example, to try to make it more clear. So I will go for down here, for example, for this temperature, which means the green will be the lowest, the red and orange will be the highest. Okay. So for example, here, yes, you can see, for example, the more green means it's a good average. Okay, so I can do like this. See, this is having a better average on 9.6 millisecond. And for example, this one have nothing because it doesn't have any points. This one 12.27, 9.8, and this, for example, 330.49. That means that it's having the worst performance. So this is now you can use the data uh, to visualize your all the polygons. So all the now the data are working together, and also you can even either now not only mapping, you can also do like kind of bar charts, line charts, CDF. All the data now are being combined using this kind of spatial joins, even it was just combined through the coordinates. One point important to highlight, for example, I have here the code, this one, for example, this is or the site ID. Let's click here and add this one show as a filter. If I go to the show filter here, you find that in the left side here, you have all the sites. So whatever null, this means the points outside doesn't have any information. So if I click this, remove the null, you'll find only it's keeping now all my points, right? Whatever outside is not there. So if I filter a specific site, I'm expecting now the site will be only coming with its own data, right? Because this is the part. Also, if I did the same, I will again keep the filter here, and I will, for example, now show the filter using the code 2, which is I will just show filter. This code 2 is actually sector ID. So if, for example, if I remove null, this will remove this kind of sector which doesn't have any points. Let's see. Yes. So now, for example, if I click here and just select a specific point, sector, see it's coming. It will keep adding. See, let's add another one. For example, 3000 here. It will be just showing the sector which is covering the area. Okay. So for example, here, sector 3. So see, it's covering only the sectors which covering the area with different colors and so on. The color code, you can change it. It's not really very good, but you can change it. But this is just about the concept. So now all the sectors are coming with different colors, different jitter, which is related to jitter speed and so on. You can even remove this one for now, just to keep one filter. So I have the filter now for that part. If I get the null, null will be showing all the points outside. So this is actually the main idea of now we discuss about the make points, spatial joins, and multi-layer map design. So let's go back to the main content, see what we covered. So we already covered now the spatial data files, right? Geometry field, this one, and we discussed about the make points as well. And we discussed about the spatial joins, right? We use this inner and we use a different method as well. We discussed about multi-layer map design. Now what we are going to discuss, we are going to discuss about these remaining functions, okay? Especially the distance, the buffer, and make line. And you can also use the area, and also for this buffer analysis, which we have a dynamic buffer, which will be including part related to the parameters, which I will have a separate session about parameters, but you can consider it as an introduction for the whatever you are going to do. So in this case, I'm going to use a different data source to start doing this kind of calculation. If I go back to the source, I will be just using the two XLS files with the site ID along with the other data points, which is just be points, pure points. I'll not use that source anymore for the meantime for the new session. So now going to the buffer area, I will go to the blank sheet again. I would like to now add a new data source, completely new data source. So I will just again go to the data source here and just make here this one, and I'll click in XLS. Okay, then I will go back here. I have part 2 from the session called buffer, and it's consisting of two data sources, which is again the points testing and site locations. So I will click them. So now I will rename this one, for example, as site locations, whatever name, it doesn't matter. So now here, the site locations, it just imported one XLS file, which is a site location. I would like to add the other one as well. So I click again, add the additional connection. I want to dump both of them on the same connection, which is V to the speed test points. Okay. So now we have the speed test point and we have the site locations. I will rename this one. I can even rename it. I will call it as a site locations. Okay. So yes. Okay. Now let's go to the geometry field here to see what we have as site locations. So for example, here, if you look into the map here, it's just having a very few information, which is related to the latitude, longitude, and site ID. This is a measure just about the site location. So if you draw this one using latitude and longitude here in the map, you can again go and disaggregate with this method. So let's add the map view as well. Map view, map background, outdoor. So let's change this one to set of automatic to make it as shapes. So I will just make my size as this icon, this shape, okay, shape file. Let's increase the size. So this is actually my site location on the map. So now I'd like, for example, to add additional layer on top of this one related to the points around here, how many points testing we have. But the main idea, again, if I told you before, you cannot add two layers if you don't have the geometry field. So first of all, you need to create a geometry field here, and also you need to create a geometry field for whatever additional data source. So for example, here, if I create an addition, I will just make a geometry field. I will call it location site geometry, which, if you remember again the formula, make point, right? Latitude, then longitude, okay? Here, these two. Then I click apply. Then I can just remove the latitude and longitude here, and I just take the geometry field and drag and drop in the details. So it will again show the same, exactly same information, okay? This is the exact same information. Now, if I got the other one, which is related to the second sheet, if you go back to data source here, the second sheet, which is under the speed test points here, okay? I would like, for example, to take it and now to drag and drop it here. But again, I would like to have a spatial join between both of them. So if I need to double click here, and I would like to drag and drop this one inside here. So I will drag and drop this one here to have a spatial join. Okay, again, this one, that's all, the sheet on the left, which is the sheet one, which is, if you remember, this was for the site location. It just have a latitude and longitude, and the one on the right having a different things like speed test, latency, latitude and longitude as well. But you cannot make that. If you remember, I cannot make this spatial join without geometry. You'll find even the intersect is not there because we don't have any geometry field for both of them. So first of all, if you would like to do a special join, you'd like to have create a calculation field. Okay. So I will create a calculation field here. So I'll call geometry. Make point, sorry, make point, latitude, then longitude. Okay. So this is the first part. So the main idea now for the second part, again, still I need to create here a geometry field. I will just create it for now without any other information, which is make point, latitude, but this one will be latitude 1 and longitude 1. What I'm expecting to be here, let's apply, then I make intersect. For now, this is just a single point, okay? Let's make it full outer for now. This also will be explaining, it will make it much better for you to just understand more. So this will make it even much better for you to understand more about the spatial joining. Okay, so now we just have a spatial joining, right, between two different sheets, which is actually XLS, and both of them are points. So if you go back now to this geometry and buffer sheet, okay, let's go back there. So now if you look into here, I drag and drop the points inside the sheet here. Let me remove it and I do it again because I did this one step before. So let me remove the points. Remember again that every time you have XLS sheets with just normal lat and long coordinates, you have to create the geometry in case, if you want to have two layers. For example, here I have the sides, right? We already created previously the side geometry. So in this case, I would like to create the new geometry for the points, right? For the second sheet, which is called points geometry, for example. Geometry. And this one shows the spelling is not correct. So points geometry, which is again the formula is make point, right? Latitude. Which one you would like to get? You would like to get the latitude 1, right? Which is this one for the new sheet, and longitude 1. Because latitude, the other one, it's for the sector, the site, right? So this one will be latitude 1, then comma longitude 1. Okay, then I make apply. Then now I have the points geometry. So I would like to drag and drop it into again, the layers, okay? So the main idea that now we did this intersection and our spatial join, right? Which is full outer, but there is no use for that part for the meantime. The only use for that now that we can plot both of them in the same map. But still here, because this is just point to point, so there is no any intersection between anything here. So the intersection point of view didn't benefit us in terms of visualization or insights, except that we can both of them together. But in order to get, for example, to have kind of your this kind of spatial join to work appropriately, you would like now to do something called buffer. So you, for example, within one site, you would like to have, let's say, if I draw this one here, which is called radial selection. For example, for this particular site, I can do a buffer. I would tell them like I would like to do the spatial join within 500 meters. Okay, just for example, within 500 meters, check all the points under this side, and for example, filter out anything outside this buffer area. So let's try first to create the buffer formula. But before creating the buffer formula, I would like to take you for the explanation for the buffer. Okay, if you look into here, we have make point, we have distance, and on the right side here we have the buffer, right? Buffer in general just need spatial points, distance, and units. I'll explain this one shortly. But the output, the output will be geometry, which means the output can be also plotted in the map. So let's go back here, there, and I will draw a buffer from the side perspective. For example, I would like to have a buffer within each side. Each side I would like to have a buffer with a specific distance. For example, here it's just very simple. I will just rename it buffer. Then the formula is buffer. Then you'll find third thing is asking you what is the geometry. Return a buffer of the given distance around the point. This is the explanation. Okay. So let me close this one for now. So here the buffer is asking for geometry. So I have geometry for the site, right? It's called site underscore geometry, which is this one, right? Then the second part is asking for the number, like what is the number. For example, I would like to have a 500 meters. Then the unit. Unit, you can just like, it should be following this for that, comma, m, this means meters. If I click apply, if you would like to have any other units, you just need to go this for the sheet here, which is, for example, this sheet, okay? Here under the explanation, you can click this link to get all the explanation as well. Under the explanation of the spatial function, you'll find that here it's like if you would like to have in meters, it should be m, kilometers should be km, miles should be mi, feet should be ft. So for the meantime, we know like as a meters, 500 meters. So I will click OK. Let me go back here, click apply and OK. Then I'll go back here. Then you'll find that our buffer here is now created as a calculated field. So I can drag and drop this one because it's coming as a geometry as well. I can drag it and drop it to the map. So let's drag and drop it to the map. See, now I have a buffer around each single side. Okay. So let me first try to make this click in the buffer area here. Okay. Then I will just play around. Let me remove the old one because I already created one before. This one is needed. So this, yeah, where is the buffer? Let me again. Okay, let me drag and drop the buffer again here, just to make it more clear. So now here is a buffer. So just let's reduce the opacity a little bit. Okay, so let's more. So we mentioned that it's 500 meters. Just to confirm this, go to the tool here. Okay, in the map tool. Just hover over here. Then you will find this kind of called radial. But before doing this one, you need to change the map. I'll do here. Okay, this one. Okay, then I will just do like this. Let's actually feet. Let's change the measure first. Let's change the measure to make it based on meters. Okay, so just to confirm this size. So you need to go to map in the top here, then map options, then show the scale. Scale will be coming down here, 1000 feet if you look into this area. Then again into the map. Okay, change the unit. Map options. Then you'll find this unit. Make it meters, metric. Okay, this is just close it. Now let's select this radial, this one, and take it from the center point just to measure. It should be 500, almost exactly 500. See, this is our buffer now, and you can keep changing that part. So for the meantime, we have the buffer, okay, but still the formula which we have done, or the spatial join which we have done, doesn't yet really do any filterization, or doesn't do any spatial join, because it's done between point to point. So in case if you'd like to do this spatial join using this buffer, for example, I would like now to keep only the points falling within the buffer, and anything outside I need to discard it. So I need to do this inner join. So to do the inner join, you must do it with a buffer condition. Let me explain more. I will go again to the data source, bottom left here. Then I will modify on top of the current existing, let's open the physical layer. Double click here. Then I would like to modify on top of this existing one. I will just double click again. Okay. Here. So what I need to do, for example, here I'm telling them from the left side, which is a site, right? I would like from the side here, I would like to filter out the data, okay, based on the, this is edit, go to the edit, make point edit here. So I can make a formula that I will tell them, just I need this inner relation, but from the data source, which is the site ID, I will just make edit join here. And instead of make point directly, I will just do a buffer formula again. Then inside the buffer point, I will tell him for the sites, make point, latitude, okay, comma longitude. Then I will tell him I need to filter it only within a buffer area, for example, 500 meters. So I will make comma, then M, then comma M, then it's already closed here. So now like this one. So what is this basically telling them? They're telling that it's saying from the site location, I have a 500 meters buffer. From this 500 meter buffers, I need to have intersection with the points. So anything within the buffer, which is 500 meters, you should get it inside and discard whatever outside the buffer, which is 500 meters. So what I'm expecting now, I'm expecting once I go here for this geometry feed, this one, once I go and I update the information, I found that everything will be discarded except the points within the buffer. So let's see, go back to the data source and again edit our location here, this one, and again this one because I moved it out. So I will make it again buffer quickly, make point, then I will say latitude 1, longitude, then I will take 500, dash M dash, then I will close this one, apply. So now it's being updated. So what I'm expecting now, if I go back here to the geometry buffer sheet, which I was using it for our work. So I go back here. See, now very good. See now our buffer, which is being created before, which was 500 meters. Let me again for this buffer just reduce the opacity a little bit. Okay. Here. Okay. You'll find that all the points, okay, here is our points, right? Let's make it as a point just to be more clear and make it, for example, yes, let's keep it blue, size, example, increase a little bit, okay? All the points within the buffer 500 meters, we have only these points for the meantime. But anything outside is being discarded. Even if you go back and reduce it a little bit for 200 meters, it should again discard more points. It will be, let's do it, for example, 200 meters. Here I will double click again. Then here for within the buffer, I will edit location. You can just make this one, for example, 300 meters. Let's do it 300 meters. So this one will be even reduced further. See, it's also have a number of less points, and even if you modify your buffer area here, edit, and make this one as well 300, you'll find that it's exactly matching with whatever you have done. So it's just 300, keeping all the points within the 300 point. So the good idea about that part, sometimes your data will be only XLS sheets. It will not be a spatial files. So if you would like to do this kind of joining, you can use this kind of methodology. For example, you have a site or an area, and you would like to calculate a specific buffer, and would like to do a spatial join between both of them. So you can get use of this two combination, which is MakePoint, to convert your latitude and longitude into geometry, and at the same time to use a buffer in order to do this kind of spatial join. This is the main idea about that part, and this is how we are using the spatial join along with the buffer calculation. So let's move now to the next part of how to calculate the distance from, for example, this side towards all the points here, and later on how to make a line from the side, which is this red points, towards the other blue points. So now let's calculate the distance from the size towards each point. Okay, it's very simple. If I go here to the calculated field, create calculated fields, I will just call it, for example, now distance. Then the formula is distance as well. Okay, this you will find that this is one is asking you return the distance between 2 points. Okay, but again, it requires to have a geometry between first point and second point, because if you look into the right side here, it said make point, then the latitude longitude. This means it's converting the points into a latitude longitude into geometry. So this means I need here inside this one, I would like to calculate the distance from the side towards the points, right? So I would just say side geometry, right? Then comma, for example, points geometry. Then I need the unit. Unit would be, for example, in meters as well. Okay, and I would like to have the units in meters. Then now you have the feed distance calculated down here. So if I drag and drop the distance, for example, into the points here, I will just click here into the points. Then I will drag and drop the distance to the tooltip here. Once I drag it, the drop in tooltips, now I would like to hover over the points just to see how much distance we have. For example, if I check here, this is 325.7 from the side. This one, for example, 196.2. This one, 243.7. So let's try to do an exercise just to confirm this calculation. For example, here, this is around 240 something, and this one points around 390. So let's see again. This one is saying, see, 340. So yeah, here, around 340. I need to do it from the center. So see, it's around 340 here. Same for this point, 325. This one, for example, 250. So you can see, it's. Let me even drop the points here. Let me even drop this one distance to the label as well, just to see. Okay, so now let's do again the draws again, just to confirm. For example, here I will draw from the center toward this one around 340, this one around 200, right? Then at the very edge it's around 480, correct? So now it's drawing the distance. But there is one tricky point I would like to highlight here. If you check this particular point, see it's very near to the side, right? But it's showing now 448. Why? Because it's randomly take the distance toward this side, not toward this one. So this means at some points, if it's like being falling between two different sides, the system might take random decision, either the highest or the lowest. For example, here it decides to take the one to the far away side, which is 400 something, right? However, from this location, it should be around 140 or 130, right? So in this case, maybe we need to tune our formula a little bit just to calculate the minimum distance. I will do a formula to tell them from the points, calculate the minimum distance toward the side. So calculate all the distance, but for all the sides, but take the minimum one. For example, if this one have a two measurement towards two sides, then take the minimum. Let's see an exercise for that. So this one 448. So now I would like to calculate the new formula to calculate the minimum distance, not the overall distance. So now I have a ready formula. I will show you because it's kind of slightly, I would say, nearest distance. I'll call it nearest distance, okay, in meters. Okay, now if you look into this one, let me modify this one a little bit here. This is called unique test ID. I'll explain shortly. Then you have the side geometry. Side geometry. Okay, what this one means, there is something called a fixed formula. Okay, this fixed formula, if you read it, this is under something called level of details. I will give also an additional session about this part because it's kind of complicated, but quickly, this one says computes and aggregated using only the specified dimension. So here I'm just specifying from the points, the unique points. This is unique test points is related to these points. Each points have a unique ID. From this unique ID, calculate all the distances. For example, this means that, for example, here, for this particular point, as an example, calculate the distance towards all the sides, towards this one, towards from this one to here, 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 from this one to here. So from the point, calculate the distance towards all the sides. Okay. Let me again explain. Okay, see, so it's saying that now I need to calculate the distance towards from the points towards all sides, but return only the minimum. So, for example, if it's being calculated from this point to this side, and this point to this side, and this point to this side, it's just telling after you finalize all the distance calculation, please return only the minimum one, right? As mentioned in the formula here. As mentioned in the formula here, right? Just return the minimum distance. This is after saying after calculation, all the calculation. So the first part, fix it, is just specifying that for this particular point, for each point, you just select it, then do all the calculation towards the others. This is the main idea. So if I apply this one now, and I drag and drop this one again into the tool tab under the points, now expecting to have a two different distances. Look into this one. Let me remove the label. Okay, now look into here. This one, look, you'll find two things here, right? Distance and nearest distance. The distance is 448, while the nearest distance is 128, because the LOD and the formula I just showed, which is fixed and other things, the two parts, is just calculated the nearest site, nearest distance toward the sites. So take the minimum distance or the nearest distance, which is 128, which is actually it's logically it become from this point toward this one, and it's ignored this point to this side. So this is in case if you'd like to, and this is usually what we do. We calculate from the side towards or from the points toward the nearest sides, not the opposite way around. So this is just to avoid any kinds of confusion. This is how how we can do it. But again, I will be explaining this LOD in more details. Maybe it's not clear here, but I will give more practical examples later on in the next sessions about, in general, the level of details calculation, which is using fixed and other things as well, which is very, very important sometimes in our analysis. So this was about the distance calculation. Now let's move to how to make line from the side towards the points. See, integrity in that. So it's need to be again points to points or special points with the coordinates. So actually, this is the easiest part for how to create a line. So it's just very simple. You need to go again to the create calculated field through clicking here. So I'll click here, create calculated field. Then, for example, I will name it as line. Then the formula is called MakeLine. Okay, then it's just saying start, and then this should be between two different points. So we'd like to calculate from the side, right, towards each and every single point to have a line, right, to be like this. I should see it like this. So let's see. Now you need to have from the side, correct, side geometry, this one, towards the point geometry, right? Then I'll close. It will be like this one. See, it's coming as a geometry as well, because see the color here, blue, and have this kind of, so I can drag and drop in the map to create additional layer. See, now I have a line from each and every single point. If you look into this, for example, it's having a small line here from this side to this point, and another line from this side toward this point, right? So it's created now lines from the side toward each and every single point. Now let's move to the last part, which is as well very interesting, in case you would like to have a dynamic buffer and also to do something called in-range calculation. So let's see what we have in the last part of this session. So now let's discuss about how to have a dynamic buffer. For example, I would like to play around with this circles dynamically, like in the dynamic way. For example, now I have it fixed to 500 meters, right? If you recall, we have our buffer here. And if you right click and edit it, Let's just fix it to 500. So I would like to make this 500 as dynamic, so I can play around whenever I want with any distance. So in this case, you need to work with something called create a parameter. Again, I will be covering all the top cases of the parameter and explain the parameter details in different session. But for the meantime, let me explain what it means. So if you right click here, for example, if you click here or right click down here, okay, you'll find that there is something called create parameter. Let's create it now. It's just telling you, for example, I will tell him this is, for example, P buffer distance. I'll explain shortly what this means, but let's call it like this. So for example, I need it float. I need the current value to be 500. This will be the start value. Then I need to have it as a range. So for example, here I'm telling him this parameter, I would need the minimum value to be, for example, 50 and the step side to be 50 as well, and the maximum to be 500. So this will be my maximum buffer and this will be the minimum buffer. So I'll click apply and the step will be 5. So it will increase, if you increase the step 50 to 100 to 150 and so on and so forth. And the starting value will be 500. So I'll click OK. Now I have this, see in the bottom down here, there is additional thing created called parameters. So if you would like to have this buffer now a dynamic way, for example, to change it whenever on fly, you need to now edit within the buffer formula. So this buffer formula, you need to go here, click edit. Then this value, which is 500, you just need to replace it by the parameter, which is called P parameter buffer. P stands for parameter, buffer distance, parameter for buffer distance. So I click apply. So now I have it. It's still as it is because I give the initial value as, if you remember, as 500. So if I take now this parameter in the bottom down here, which is created before, I just right click, then I say show parameter. It will be coming at the top right here, right? So what I'm expecting now, this is the initial in start value. So if I'm changing this one, I'm expecting this circles will start to reduce. For example, the maximum is 500. If I reduce a little bit, see what will happen. See the circles start reducing here. Okay, so for example, what is the use case for that for now? For example, I would like to, if my buffer now is 300, I would like to calculate how many points is out of range. Okay, so for example, I know that this points which is out of range of the buffer. For example, this these few points outside here, which is these, for example, points, right, and this one is out of this particular buffer, right, area, right, and same for that part, same for that one, and so on and so forth. So for example, let's calculate something called in range. I would like to do another one, to click it, call it in range. So I would say in range, I would say in range called nearest the distance, which I calculated before between the points for the size. I would say less than, for example, less than the parameter which we call it, called p buffer distance, this one. Okay, so I click apply. I have now a range. This is coming as pollen value here. Okay, I can directly take it and drag and drop it inside the points here, points geometry into the colors. See now I have in the right side here, I have true and false. True means this is in range of the buffer, because the formula of the in range, again, just to recall quickly, the formula of this part in the in range, if you right click here, the formula of the range, it's saying that the nearest distance, which we calculated before, the distance between the points for the side, which is, for example, here 128, nearest distance, towards the buffer distance, which is this parameter. So, for example, it's saying if it's nearest, if it's less than this one, then it will be true. Otherwise, it will be false. So, for example, at this point, it's 128.6, so it's less than the 300, right? So this one is true, and this one, for example, is larger because the nearest distance is 486, so it's greater than 300. So that's why it's coming in range. So this is one of the use cases. For example, if I kept reducing the buffer, you will find that the color will be changing. For example, this coming outside now. More, if you go more down, this one, for example, will go blue, correct? So this is actually one of the use case. The last part I would like to discuss of how, for example, to calculate, if you would like to calculate, you have areas or polygons and you would like to calculate the area of, or the size of the area of any specific polygon. For example, here I would do for the buffering. So you can just go create calculated field. I'll just say area of the buffer. It will be fixed for all because we have the same buffer area, but this can be done for any other exercise. For example, specific polygons, areas based on your data. So it's just called very simple area. It's just saying what is your polygon, where you would like to calculate the size. So I'll just say I'd like to calculate it for the buffer area, all right? This buffer area. Then I'll tell him, comma, the unit I would like, for example, to have it as meter as well. Okay, so I just make apply. So if you drag and drop now this area here, it will give you the exact, let's drag and drop it anywhere, for example, within the site or within the buffer area here as a label, for example. So you find that it's this kind of unit, you can play around, but it's fixed because all the buffer have the same size. So that this was the last part about uh, today's video. So we covered almost everything in the session content here. We covered almost everything. So now we are almost done with all what you need to do about the mapping or the working with maps in Tableau from the very basics till the very advanced level. So I hope if you like the content to spread the knowledge and to subscribe to the channel and to press like and drop a comment. Thank you very much and see you next video.